In the stillness of the night sky, far to the south, a faint red star glimmers with quiet persistence. To the naked eye, it is almost invisible, a mere ember against the infinite black. Yet this star, Proxima Centauri, is closer to us than any other, a neighbor in the cosmic wilderness. Orbiting within its faint light is a world both familiar and foreign, a planet called Proxima b. It is rocky, massive enough to hold an atmosphere, and it circles within the region scientists call the habitable zone, where liquid water, and perhaps even life, might endure. It is, in cosmic terms, right? Next door, only 4.24 light-years away, but in the language of distance, that number becomes unfathomable. 40 trillion kilometers. A gulf so vast that with today's fastest spacecraft, it would take tens of thousands of years to arrive. It is the paradox of our age. The nearest Earth-like world may also be forever out of reach, and yet it tempts us. It ignites the old fire of longing that has carried our species across oceans, deserts, and skies. Could this pale planet be our second chance, a refuge should Earth falter? Or is it a mirage, luring us with promise, but destined to remain a dream? The story of Proxima b is not merely a question of astronomy. It is a meditation on distance and desire, on what it means to seek beyond the boundaries of our world. It is the tale of how close we stand to another sun, and how impossibly far. In August of 2016, a quiet announcement sent ripples through the scientific world. The European Southern Observatory confirmed that, orbiting the faint red star Proxima Centauri, a planet had been found. It was small, rocky, and resting within the narrow band of space where liquid water could exist. To those who listened carefully, it was as though the universe had whispered, "You are not alone." The discovery was not made through direct sight. No telescope captured the silhouette of a world suspended in alien skies. Instead, the planet revealed itself through the subtlest of signatures, hidden within the trembling light of its star. Astronomers had long known that planets exert a gravitational pull on the stars they orbit. When a planet tugs on its star, however gently, the star does not remain still. It wobbles, ever so slightly, shifting its position back and forth. This wobble imprints itself upon the star's light, altering its spectrum in a rhythm that betrays the presence of an unseen companion. This was the method of revelation, the radial velocity technique. Using the high-accuracy radial velocity planet searcher, HARPS, a precision spectrograph at the La Silla Observatory in Chile, scientists traced the faint oscillations of Proxima Centauri. They measured the subtle shifts in wavelength, the tiny red shifts and blue shifts that signaled motion toward and away from Earth. Each fluctuation was smaller than the pull of a walking human on the Earth's crust, yet the instruments could detect it. Behind the campaign stood Guillem Anglada, Escude, a Spanish astronomer who led the international effort. Nearest star. Their endeavor, known as the Pale Red Dot Campaign, was meticulous, sustained, and filled with uncertainty. Proxima Centauri was a difficult star to study, dim, restless, often flaring. Its turbulence threatened to mask the faint signal of any world that might lie in orbit. Yet after months of observation and painstaking analysis, the evidence became undeniable. The wobble was consistent. The rhythm was steady. A Proxima b Its minimum mass appeared to be just over that of Earth. Not a gas giant, not an ice world, but something solid, something potentially familiar. And more astonishing still, it circled its star within the so-called habitable zone, the orbital region where surface temperatures might allow liquid water to flow, oceans to gather, and atmospheres to breathe. For the first time, humanity had identified an Earth-like planet, not across the vastness of the Milky Way, but within our cosmic neighborhood, just over 4 light-years away. Some likened it to standing on the shoreline of a great ocean, gazing at the first island across the water. The context deepened the gravity of this moment. In the preceding decades, the search for exoplanets had blossomed into a revolution. In 1995, the first planet around a sun-like star was confirmed, 51 Pegasi b, a giant world orbiting blisteringly close to its star. Since then, the tally had grown into the thousands. NASA's Kepler Space Telescope revealed that planets were common, perhaps more numerous than stars themselves. Yet most of these worlds were impossibly far, hundreds or thousands of light-years away. They were points on charts, distant and unreachable. Proxima b was different. Its nearness changed everything. For the first time, the dream of another Earth did not belong to distant galaxies or unreachable stars. It belonged to the system next door, and yet there was tension beneath the wonder. The star it circled, Proxima Centauri, was not like our Sun. It was a red dwarf, faint and unstable, known for bursts of violent radiation. What did it mean for life to exist in such a place? Could a planet so close to its star hold on to its atmosphere, or would it be stripped bare by relentless flares? The discovery raised as many questions as it answered. Still, the emotional weight of that August day cannot be understated. Humanity had glimpsed a reflection of its own world, not in imagination, but in data. In the pulse of starlight, there was proof, a rocky planet orbiting the nearest star. The possibility of oceans, of continents, of alien skies shimmering under a crimson sun. Philosophically, the discovery pressed upon an ancient ache. For centuries, thinkers had debated whether other worlds like ours existed. From Giordano Bruno, who dared to imagine countless inhabited suns, to Kepler, who wondered about the lives of beings beyond Earth, the question had persisted, unanswered. In Proxima b, the question suddenly felt less abstract, more immediate. Here was a tangible world, so close it could almost be reached. It was not simply a scientific finding. It was a mirror, a reminder that Earth might not be singular, that our fragile blue sphere could have a counterpart, whispering across the interstellar gulf. The methods that led to its detection embodied the precision of modern science, but the reaction it stirred was timeless. Wonder, longing, the spark of curiosity that propels humanity outward, ever searching for kinship among the stars. In that moment of discovery, Proxima b ceased to be a mere possibility. It became a destination, distant, unreachable for now, but real. And in its reality, it redefined the boundaries of our imagination. When the data was first confirmed, the scientific community felt a tremor, not from the heavens, but from within. Proxima b was not merely another addition to the catalogue of exoplanets. It was a revelation, a rocky planet circling the nearest star beyond our sun, resting in the delicate zone where warmth and cold might balance into life. The implications. were staggering. In the decades before, planets had been discovered in bewildering diversity. Hot Jupiters searing against their stars, super-Earths clinging to infernal orbits, frozen giants circling in silence. But an Earth-mass planet in a temperate orbit this close, that was something altogether different. Its measured mass, at least 1.17 times that of Earth, placed it firmly in the category of rocky worlds. It was not a gas giant cloaked in storms. It was something solid, familiar, tangible. For the first time, a planet we could imagine standing upon had been revealed in the system next door, and its orbit deepened the sense of wonder. Proxima b circles its parent star at a distance of just 0.05 astronomical units, a mere 5% of the Earth-Sun distance. To our intuition, such proximity seems perilous. Yet Proxima Centauri is a red dwarf, a star far dimmer and cooler than the Sun at that distance. The warmth received by the planet could allow temperatures where liquid water, the essential solvent of life as we know it, might exist. Not too hot, not too cold. A precarious balance, but one that falls within the celebrated habitable zone. For astronomers who had spent lifetimes searching the sky for Earth's analogs, this was extraordinary. It meant that the nearest star, the one visible from the southern hemisphere as a faint red glimmer, already harbored a candidate. No need to peer across thousands of light years. The possibility of another Earth was not far away in the spiral arms of the galaxy. It was right beside us, but wonder has a shadow, and Proxima Centauri casts it deeply. The star itself is no ordinary companion. Classified as an M-type red dwarf, Proxima is smaller, cooler, and older than our Sun. It shines at less than 1% of the Sun's luminosity. To human eyes, it would never blaze. It would only smolder, dim, and faint. But what it lacks in brilliance, it compensates with ferocity. Red dwarfs are notorious for their instability. Their magnetic fields churn violently. Their surfaces convulse with storms. Proxima Centauri, in particular, is a flare star, prone to sudden bursts of radiation, hundreds of times more powerful than anything our Sun produces. In 2019, astronomers recorded a flare from Proxima that briefly increased its brightness by a factor of 14 for a world orbiting so near. This was not a distant light show. It was an event capable of stripping atmospheres, scorching surfaces, and sterilizing oceans. Thus, the paradox of Proxima b emerges. On paper, it rests within the habitable zone. In reality, it lies beneath the fury of a volatile star, where Earth receives a gentle balance of sunlight. Proxima b may endure constant bombardment of ultraviolet and X-ray radiation. This contradiction shook astronomers profoundly. A planet so close, so Earth-like in mass, should have been a triumph, an affirmation of the belief that habitable worlds are common. Instead, it became a riddle. Could such a world truly support life? Or does its very nearness to its star render it barren, a mirage in cosmic disguise? The questions multiplied. At such close distance, the planet is almost certainly tidally locked, its rotation synchronized with its orbit. One hemisphere forever turned toward Proxima's crimson glare, the other locked in eternal night. If so, its landscapes would be extreme. A dayside scorched by perpetual dawn, a nightside frozen in darkness. And yet, along the narrow line between These hemispheres, the twilight zone might persist, a strip of temperate climate, where water could flow and life might cling. Here, science met imagination. Could alien forests stretch across this twilight band, basking in eternal sunset? Could oceans carve out a ring of habitability, even under such strange skies? Models of atmosphere and climate were run, exploring scenarios in which winds, oceans, and magnetic fields might redistribute energy and shield life. Some simulations suggested hope, others painted sterility. Each answer seemed to fracture into new uncertainties. This duality is why Proxima B shook science so profoundly. It was not only that a nearby world might be habitable, it was that this same world embodied the knife-edge fragility of habitability itself. A reminder that Earth's balance is not inevitable, but rare, contingent, and delicate. The philosophical weight of the discovery pressed upon human thought. For centuries, the question of other Earths had been bound up in hope. The Copernican revolution displaced humanity from the center, but it also implied abundance, countless stars, countless worlds. Yet Proxima B forced a reconsideration. What if the closest world is also hostile? What if the promise of habitability is undermined by the violence of stars themselves? In this tension lies a deeper truth. Life may not simply require the right distance from a star. It may require the right kind of star, stable, generous, forgiving. Our sun is one among billions, but its relative calm may be rarer than once believed. Perhaps Earth is not just one of many oases. Perhaps it is exceptional, a fragile jewel set within extraordinary circumstances. And yet, science does not despair. The discovery of Proxima B lit a fire, not of resignation, but of inquiry. It became a target, a challenge, a mirror. If life can endure near such a star, it would reveal resilience far beyond human expectation. If life cannot, it would still teach us about the boundaries of habitability, the margins at which biology falters to astronomers. Proxima B is both promise and warning. It whispers of oceans and atmospheres, but it also hisses with radiation. It invites dreams of second homes, yet cautions that not all neighbors are hospitable. This is why the news in 2016 resonated so deeply. Proxima B was not just another entry in the catalog of exoplanets. It was a revelation at the threshold of our imagination. A planet close enough to stir longing, yet hostile enough to provoke doubt. It forced humanity to gaze at the nearest star and ask, what does it mean for a planet to be habitable? And more urgently, what does it mean for us to dream of reaching it? In that contradiction between possibility and impossibility, hope and hostility, lies the heart of Proxima B's mystery. A world so near, yet perhaps forever beyond our embrace. At the edge of the southern sky, faint and unassuming, lies the closest star to our own. To most who look upward, it is invisible, drowned in the brilliance of its brighter companions. Alpha Centauri, A and B, yet hidden in their shadow, is a star so modest it would vanish if placed beside the sun. This is Proxima Centauri. It is a red dwarf, a category of stars, both common and mysterious. Red dwarfs make up nearly 3/4 of the stars in our galaxy. They are small, their diameters a fraction of the sun's, their light a soft crimson glow. They burn cool, with surface temperatures barely half that of our own star. To human eyes, if viewed from an imagined surface of one of its planets, Proxima would appear as a dull ember in the sky, never reaching the golden blaze we take for granted on Earth, and yet their modesty is deceptive. What red dwarfs lack in brightness, they repay with longevity. While the sun will exhaust its fuel in about 10 billion years, red dwarfs burn with such frugality that they may endure for trillions. They are the universe's slow breathers, promising stability long after stars like the sun have died. But longevity is not kindness. Proxima Centauri is no serene beacon. It is a restless star, its surface roiled by turbulence and magnetic storms. Unlike our sun, whose activity ebbs and flows in cycles, Proxima is prone to sudden and violent outbursts. Stellar flares erupt unpredictably, hurling torrents of ultraviolet and X-ray radiation into space. In 2019, a flare was observed that briefly multiplied Proxima's brightness 14-fold. To an orbiting planet like Proxima b, bound so closely to its star, such an eruption would not be a passing shimmer. It would be a storm capable of stripping away atmospheres, disrupting climates, and bombarding any surface life with radiation intense enough to sterilize oceans. Here lies the contradiction of Proxima Centauri. It lives long, but lives violently. It can nurture planets for eons, yet in the same breath it may extinguish them. Proxima b circles this volatile star at only 0.05 astronomical units, a mere 7 million kilometers. In comparison, Earth orbits the Sun at 150 million kilometers. To survive at such proximity without being incinerated, Proxima b must rely on the faintness of its parent. Red dwarfs release far less energy than the Sun, so their habitable zones are pulled inward, hugging tightly to the star's glow. This closeness brings consequences. Proxima b is almost certainly tidally locked, its rotation captured by the gravity of its star. One hemisphere is condemned to perpetual day, bathed in an eternal crimson glow. The other lies in endless night, frozen under the absence of light. The image is haunting, a world divided, its landscapes sculpted not by seasons, but by permanence. On one side, continents blister beneath a sun that never sets. On the other, glaciers build in darkness without end. Between them lies the Terminator line, a ring of twilight where day and night meet in balance. Some scientists speculate that here, in the band of perpetual sunset, a temperate climate might exist. Winds could circulate warmth, oceans could carry currents, and a narrow strip of life might be possible. But such a balance is fragile. If Proxima b possesses a thick atmosphere, it might redistribute heat, tempering extremes and softening the brutality of tidal lock. If the atmosphere is thin, stripped away by centuries of flares, the planet may be barren, its day side scorched, its night side a frozen wasteland. This uncertainty reshapes humanity's understanding of habitability. For decades, the Goldilocks zone was imagined as a simple band of distances where liquid water might endure. Too close, and oceans boil. Too far, and they freeze. But Proxima b teaches a harsher truth. The Goldilocks zone is not simply a matter of distance. It is a matter of star type, of magnetic protection, of atmospheric resilience. A planet can orbit within the mathematically perfect zone and still be uninhabitable. Red dwarfs, once thought promising for their longevity and abundance, now present a puzzle. Could their volatility allow life to adapt in ways unimaginable on Earth? Or do their flares extinguish the very conditions they promise to provide? Philosophically, the paradox cuts deeply. The most common stars in the galaxy may be the least forgiving. If life requires a gentle star, stable and temperate, then the universe may be filled with planets that look like homes but are unlivable. Perhaps our sun, with its balance of brilliance and restraint, is rarer than once believed. Perhaps Earth's story is not inevitable, but exceptional, and yet the mystery lingers. Even under the violent hand of Proxima, there may be paths to survival. A strong magnetic field could shield a planet, deflecting the storms of radiation. A dense atmosphere, rich in greenhouse gases, could trap warmth on the night side and blunt the scorch of the day side. Life itself, if it emerged, might adapt to extremes, dwelling underground, beneath oceans, or within sheltered environments. To consider such possibilities is to expand the imagination of biology itself. On Earth, life has endured hydrothermal vents, radiation-rich wastelands, and the crushing pressures of the deep sea. If Earth's biosphere thrives on resilience, might not Proxima be, in some form, echo that resilience under its alien sun? Still, the uncertainties are vast. Telescopes glimpse only fragments, the mass of the planet, the flare of its star, the faint hints of orbital rhythm. What lies upon its surface, seas or deserts, skies or void, remains hidden. Proxima Centauri guards its secrets well. What is clear is this: Proxima, the nearest star to the Sun, is no gentle neighbor. It is both a promise and a warning. Its longevity suggests stability beyond measure, yet its violence suggests fragility beyond survival. The Goldilocks zone, once thought a simple formula, now becomes a shifting mirror, reflecting back humanity's assumptions. Life may not be a common flame kindled wherever conditions appear mild. It may be a rare fire, requiring stars, both nurturing and restrained. And so, Proxima Centauri forces us to look again at our own sun, golden, stable, steady, and recognize its gift. Earth orbits not only within a habitable zone of distance, but within a habitable zone of fortune. The star that hosts Proxima b is, in every sense, a paradox. It is long-lived, yet restless, dim, yet violent, capable of sustaining a planet for trillions of years, yet capable of erasing that planet's potential in an instant. For humanity, this paradox stirs a deeper reflection. If the nearest star is both promise and peril, then perhaps the search for other worlds is not merely scientific, but existential. It is a search for mirrors, for lessons, for reflections of what life demands. Proxima Centauri stands as the closest teacher, and Proxima b, bound in its crimson light, is the first lesson, a reminder that not all suns are kind, and that the dream of habitability is as fragile as the stars themselves. The discovery of Proxima b was not the end of the story. It was the beginning of a deeper pursuit, a search to peel back the veil of distance and glimpse the hidden nature of a world orbiting the nearest star. Yet, in astronomy, discovery often comes not with a flash of certainty, but with years of patient listening, collecting fragments of light and interpreting shadows cast by the unknown. After the 2016 announcement, the focus sharpened. the HARPS spectrograph, which had first revealed the subtle wobble of Proxima Centauri, continued its quiet surveillance. HARPS was designed to detect velocity shifts as small as walking speed. Night after night, it traced the trembling heartbeat of Proxima's light, refining measurements, confirming the rhythm of the unseen planet. What emerged was consistent, a world with a minimum mass slightly heavier than Earth, locked in orbit every 11.2 days. But HARPS could not see Proxima B itself. It could only infer its presence, like hearing footsteps in the dark without seeing who makes them. To probe further, astronomers turned to other instruments, each bringing a new fragment of perception. The Atacama Large Millimeter Submillimeter Array ALMA, perched high in the Chilean desert, offered another window. ALMA's sensitivity to cold dust and faint emissions allowed scientists to search for circumstellar material. Some studies hinted at the presence of dust belts surrounding Proxima Centauri, perhaps analogues to the asteroid or Kuiper belts in our own system. If true, these belts could influence Proxima B's climate and history, shaping its potential for habitability. There were even whispers of structures in the data that could suggest additional worlds, or even the faint shadow of an exomoon. None were confirmed, but the possibility was intoxicating. Proxima B might not be alone. The next frontier lay in the question of atmosphere. Could this small planet, orbiting so close to a violent star, retain the delicate skin of gases that makes life possible? Without an atmosphere, oceans cannot endure, climates cannot stabilize, and biology cannot breathe. To answer this, astronomers began modeling scenarios with increasing complexity. They imagined Proxima B with thick atmospheres of nitrogen and carbon dioxide, capable of redistributing heat between its locked hemispheres. In these simulations, the eternal day did not scorch, and the eternal night did not freeze. Instead, winds carried warmth across the planet, creating temperate regions along the twilight zone. In some cases, vast oceans moderated the extremes, wrapping the world in a global circulation that made parts of it surprisingly Earth-like. But other models painted a bleaker picture. Under the assault of Proxima's flares, atmospheres could be stripped away in a few 100 million years. Radiation could dissociate molecules, letting lighter elements escape into space. A planet once warm could become barren. Its seas evaporated. Its skies vanished. This tension between possibility and loss became the heart of the investigation. Proxima B was not simply a planet. It was a mirror reflecting the fragility of habitability itself. New instruments promised sharper vision. The James Webb Space Telescope, with its vast segmented mirror and infrared eyes, emerged as the sentinel of the search. Though designed primarily to probe the earliest galaxies and the atmospheres of larger exoplanets, Webb's capabilities offered a tantalizing possibility. Could it detect the spectral fingerprint of gases around Proxima B? Could it catch the faint absorption lines of carbon dioxide, water vapor, or oxygen? Signs not just of habitability, but perhaps of life itself. The answer is still awaited, complicated by the fact that Proxima B does not transit its star from Earth's perspective. Without the shadow of the planet crossing the star's disk, the most direct atmospheric measurements are out of reach. Instead, astronomers must rely on indirect methods, thermal emission, reflected light, or subtle spectral variations. Each is faint, elusive, near the edge of what is possible. And yet, science advances by pressing against these edges. Even the absence of evidence becomes evidence. If Webb or other instruments find no trace of atmosphere, that too will speak of the violence of red dwarfs, of the resilience or fragility of rocky worlds. Meanwhile, climate models continue to explore Proxima B's possible faces. Some envision a terminator habitability, where life might flourish in the narrow band of perpetual twilight, bathed in dim but constant glow. Others imagine deep oceans, circulating warmth beneath ice, creating hidden biospheres, shielded from stellar wrath. Still others ponder whether volcanic activity could replenish atmospheres lost to flares, sustaining a fragile balance across eons. What emerges is not certainty, but a spectrum of worlds. Proxima B as oasis, as wasteland, as frozen husk, as steaming ocean planet. The data does not collapse these possibilities. It sustains them, like multiple reflections of the same face seen in shifting mirrors. Hints of dust rings and potential companions complicate the picture further. If Proxima Centauri indeed hosts belts of debris, collisions may have bombarded Proxima b for billions of years, shaping its surface, enriching it with volatile materials, or sterilizing it with impacts. If exomoons exist, they may influence tides, climates, even stability of orbits. The system is alive with complexity, far beyond the simple sketch of a planet in the habitable zone. And so, Proxima b remains not a world, but a question written in spectral lines and orbital rhythms, in simulations and uncertainties. We see only signatures, the faint wobble of a star, the subtle glow of dust, the mathematical possibility of climates. We do not yet see the world itself. This fuels both mystery and humility. Astronomy is an art of shadows, of inferring realities from fragments of light that travel years across space. Proxima b, though close in cosmic terms, is still a distant dream. It may be an Earth-like twin. It may be a barren rock. It may host oceans under crimson skies, or be locked in silence and ice. Philosophically, the pursuit reflects humanity's own condition. We are creatures who seek meaning in the unseen, who build entire narratives from whispers of data. Proxima b may be less a destination than a mirror of our own longing, a screen upon which we project the question, are we alone? The deeper investigations do not resolve this longing. They sharpen it. Each instrument harps, Alma, Webb, expands the possibilities without closing them. Each model of climate opens as many doors as it closes. Each flare from Proxima Centauri reminds us that life's conditions are fragile, precarious, contingent. And yet, this uncertainty is not despair. It is wonder in its purest form, the kind of wonder that humbles, that stretches the imagination, that insists the nearest star might harbor a secret still veiled. Proxima b does not yet answer us, but it compels us to keep asking. For now we see only fragments. One day, perhaps through direct imaging with the next generation of telescopes, the extremely large telescope in Chile, or future space-based observatories designed to capture exoplanets in reflected light, We may see its oceans, or its deserts, its clouds, or its scars. We may map its dayside, glimpse its nightside, and finally know whether Twilight truly harbors life. Until then, Proxima b remains a world suspended between certainty and dream. It is the promise of data without conclusion, a signal without an image, a heartbeat without a face, and in that mystery lies its power. The nearest world, and yet forever hidden. For now, discovery is rarely an ending. More often, it is an opening, a widening of questions that ripple outward, revealing that the first answer was only a doorway into greater uncertainty. Proxima b was that doorway. Once its presence was confirmed, the mystery did not diminish. It grew, for the faint tremors in Proxima Centauri's light hinted at more than one companion. In the years following 2016, astronomers noticed additional signals woven into the star's restless spectrum. The wobble of Proxima b was clear and steady, a planetary heartbeat every 11.2 days. But overlaying that rhythm were slower, fainter pulses, signatures that suggested other worlds might be circling the same star. In 2020, evidence for a second planet was announced, Proxima c. Unlike its sibling, this candidate world appeared much farther from the star, orbiting at a distance of about 1.5 astronomical units, completing a circuit every 5 Earth years. Its mass was estimated at around 7 times that of Earth, placing it in the category of a super-Earth or mini-Neptune. It was unlikely to be habitable in the sense we know, but its presence expanded the system into something more complex, more alive with dynamics. Hints of a third planet, Proxima d, followed. Smaller, closer in, orbiting every 5 days. If confirmed, it would be one of the lightest exoplanets ever detected by radial velocity, less than a quarter of Earth's mass. These companions, real or tentative, painted Proxima Centauri not as a star with a lone planet, but as a system, a miniature cosmos at our doorstep. And with each new candidate, the questions deepened. If Proxima harbored multiple worlds, what histories had they shared? Had comets or asteroids migrated inward, delivering water to Proxima b? Had collisions sculpted its surface or stripped it of protection? Did gravitational dances between planets shape its climate, its spin, its fate? But while the architecture of the system intrigued, the true escalation of the mystery came from the star itself. Proxima Centauri, already known as volatile, began to reveal just how ferocious a red dwarf can be. In 2018, a flare was captured by observatories that dwarfed even the most violent solar storms. Within seconds, Proxima's brightness in ultraviolet light increased by a factor of 100 for a star barely visible to the naked eye. The flare was a cosmic explosion of energy, bathing the system in radiation that would have been devastating to any unprotected atmosphere. To imagine Proxima be under such a storm is to envision a fragile world enduring catastrophe. High-energy photons ionize atmospheric molecules, breaking them apart. Charged particles accelerate outward, eroding layers of protective gases. If such flares are frequent, they could gradually strip a planet bare, transforming oceans into vapor and vapor into emptiness. The irony is striking. The nearest potentially habitable planet orbits a star whose very nature may ensure uninhabitability. The proximity that gives hope is the same proximity that threatens cause despair. Scientists wrestle with this paradox. Could Proxima B's atmosphere survive under such bombardment? Some models suggest that a strong magnetic field, perhaps generated by a molten iron core, could deflect much of the radiation, shielding surface and sky alike. Others argue that even magnetic protection would falter under centuries of relentless flaring. The balance is precarious. If Proxima B retained its atmosphere, it might indeed harbor climates capable of sustaining life, even life. If not, it could be an airless husk, locked in eternal silence. This uncertainty sharpened humanity's awareness of the fragility of habitability. On Earth, the sun is stable, our atmosphere thick, our magnetic field strong. But these conditions are not guaranteed elsewhere. They are fragile coincidences, rare harmonies in a universe of chaos. Proxima B may orbit in the habitable zone by distance, yet be rendered uninhabitable by violence. The deeper scientists probed, the more fragile the dream of a second Earth became. And yet, this fragility did not diminish fascination. Instead, it intensified it, because within fragility lies resilience. Life, as known on Earth, has found ways to endure in radiation zones, in the crushing darkness of the deep ocean, in volcanic fissures spewing toxic gases. Extremophiles thrive where conditions seem impossible. Might not something similar occur? On Proxima B, could life exist underground, beneath oceans, or shielded by ice? The question is not answered by the star's violence alone. It remains suspended between possibility and impossibility. Philosophically, the paradox is profound. Humanity had long assumed that proximity meant promise, that the nearest planet in the habitable zone would be a candidate oasis, a potential refuge. But the closer we look, the more the illusion of certainty collapses. The nearest world may not be a sanctuary. It may be a reminder that habitability is rarer than we imagine. In this tension, Proxima Centauri teaches humility. It is as if the universe has placed a lesson at the nearest star, that distance alone does not define possibility, that life is not inevitable, even when the numbers suggest it should be. And yet, Proxima B still beckons, because even a hostile world holds secrets worth knowing. It is not only the possibility of life that compels us, but the boundary between life and lifelessness. To study Proxima B is to probe the edge of what is possible, to define the contours of habitability itself. As instruments grow sharper, astronomers seek to pierce the veil further. The flares of Proxima are now monitored across multiple wavelengths: radio, ultraviolet, X-ray, to understand their frequency and intensity. Models of atmospheric loss are tested against scenarios of replenishment. Imagining volcanic outgassing or cometary delivery of volatiles. Each study deepens the paradox rather than resolving it. Each flare recorded underscores the star's hostility. Yet each model of protection sustains hope. The mystery expands not because answers arrive, but because the questions multiply. And so, the narrative of Proxima B is no longer just the story of a planet. It is the story of an entire system, alive with companions, battered by storms, balanced on the threshold between possibility and impossibility. It is the story of how closeness can reveal not comfort, but complexity. Emotionally, this leaves humanity suspended. The dream of a second Earth just next door is fragile. But fragility does not erase wonder. On the contrary, it magnifies it. Because what is fragile becomes precious, and what is precious draws us closer. The expanding mystery of Proxima Centauri and its planets is not an invitation to despair. It is an invitation to humility, curiosity, and reflection. It tells us that even the nearest world may not be what we hope, but it is still worth knowing. The closer we look, the more fragile the dream becomes. But also, the more profound. The nearest star beyond the sun glimmers in silence, only 4.24 light-years away. To the human imagination, the distance feels intimate, a neighbor in the cosmic night, but to physics, it is an abyss. For light years is nearly 40 trillion kilometers, a span so immense that words collapse under its weight. To comprehend it, one must turn to numbers, and even numbers strain. Light, the fastest messenger in the universe, takes more than 4 years to cross this gulf. The spacecraft humanity has launched, the Voyagers and Pioneers, have drifted outward for nearly half a century, and yet they have only traversed a fraction of a single light day. At their current speeds, to reach Proxima Centauri would take more than 70,000 years, longer than all of recorded human history. It is a paradox that haunts astronomy. The nearest world of promise lies not in another galaxy, not across a spiral arm, but just next door. And yet, in terms of our present technology, it may as well be across eternity. The Voyager probes remind us of this scale. Voyager 1, humanity's most distant emissary, speeds through interstellar space at 17 kilometers per second. It has crossed the heliopause, leaving the bubble of the sun's influence. But even at this velocity, it would require 75,000 years to arrive at Proxima. By then, continents will have shifted, languages will have vanished, and civilizations will have risen and fallen many times over. The New Horizons probe, which gave us our first close view of Pluto, traveled even faster at launch, nearly 6 kilometers per second relative to the Sun. Yet even it would take tens of millennia to bridge the gap. These comparisons reveal the enormity of the barrier. Interstellar travel is not simply about engineering. It is about confronting the sheer immensity of space, an immensity that dwarfs human timescales. And yet, the dream persists. To cross to Proxima b, humanity must imagine speeds not of tens of kilometers per second, but of tens of thousands, not a few fractions of light's pace, but significant portions of it. The journey requires a leap, not of technology alone, but of vision. Speculative propulsion has become the language of this vision. Concepts once confined to science fiction now enter the laboratories and conferences of serious science. One such vision is nuclear fusion. Unlike fission, which splits atoms, fusion binds them together, releasing energy as stars do in their hearts. Harnessed on Earth, fusion promises propulsion with immense efficiency. In the 1970s, Project Daedalus, study by the British Interplanetary Society, imagined a spacecraft propelled by fusion pellets ignited behind it. Accelerating to 1/10 of light speed, such a craft could reach Proxima in 50 years. The design was vast, a vehicle larger than skyscrapers, fueled by thousands of tons of helium-3 mined from moons or gas giants. It was never built, but it set a framework. Interstellar travel would require stellar energy. Another idea is nuclear pulse propulsion, embodied in Project Orion. In this audacious vision, a spacecraft would hurl nuclear bombs behind it, riding the blasts like cosmic thunder. Each detonation would push it forward, propelling it to speeds unimaginable for chemical rockets. The idea was serious enough that designs were drawn, tests were made, and even Freeman Dyson lent his mind to it. Yet political and ethical barriers, the danger of detonating nuclear devices in Earth's sky, halted the dream. Still, Orion's principle remains. Only by wielding the power of the atom can we break free of interstellar inertia. Others dream deeper still of antimatter drives. Matter and antimatter annihilate upon contact, converting all their mass into pure energy, as dictated by Einstein's equation. No fuel is more efficient. A spacecraft fueled by antimatter could, in principle, accelerate 2 fractions of light speed with elegance and power. The problem is scarcity. Antimatter is not found in nature in usable quantities. To produce even a gram requires colossal energy and cost. For now, antimatter propulsion remains a dream suspended between physics and impossibility. More recent visions turn to light itself. Solar sails, vast, thin sheets pushed by photons, offer propulsion without fuel. Light, though massless, carries momentum, and with enough area, a sail can drift outward, pushed gently but persistently. Already, experiments such as Japan's Icarus and the Planetary Society's Light Sail have tested this principle in the solar system. But for Proxima, sunlight is not enough. Instead, some imagine Earth-based lasers, powerful beyond anything yet built, focusing beams upon tiny sails, pushing them to extraordinary velocities. This is the principle behind Breakthrough Starship, a project announced in 2016 by Yuri Milner and supported by voices including Stephen Hawking. The vision is radical. Instead of massive starships, send swarms of gram-scale probes, no larger than a microchip, each attached to a sail of reflective material. Earth-based lasers, gigawatts in power, would accelerate these sails to 20% the speed of light. At such velocity, a probe could cross the Gulf to Proxima in just over 20 years. These probes would not carry humans, nor even large instruments. They would be machines the size of a postage stamp, equipped with cameras, sensors, and transmitters. Upon reaching Proxima b, they could capture fleeting images and data before racing past, their journey irreversible. The challenge is immense. Aiming lasers across thousands of kilometers of atmosphere, sustaining acceleration without destruction, ensuring probes survive decades of interstellar dust. But the concept is serious, understudy, and funded. For the first time, an interstellar mission feels not like myth, but like plan. Yet there is a poetic irony here. Humanity dreams of walking upon other worlds, of planting flags under alien skies. But our first ambassadors to the stars may not be human. They may be machines, no larger than the palm of a hand, fragile, quick, and disposable. Their purpose: to look where we cannot yet go, to carry our questions outward like sparks into the dark. This irony speaks to the nature of exploration itself. Every great journey begins not with armies or cities, but with scouts. The Polynesians sent canoes across the Pacific, guided by stars, before whole civilizations followed. The star-shot probes, if launched, may be the canoes of interstellar space, frail, solitary, but bold. And so the distance barrier, though immense, does not close the dream. It reshapes it. Instead of imagining grand arcs leaping to Proxima, humanity begins with whispers of light sails and grains of machines. Perhaps in centuries, larger vessels will follow fusion craft, antimatter engines, or technologies not yet conceived. Perhaps one day, humans themselves will endure the journey. But the first emissaries will likely be silent, mechanical, and small. Philosophically, this realization carries weight. To reach Proxima b is to confront scale, not only of distance, but of time, of patience, of humility. The universe does not yield easily. It demands energy beyond measure, precision beyond comprehension, and time beyond lifetimes. Yet the pursuit itself defines humanity. To aim lasers at the sky, to hurl gram-scale probes toward another star, is to declare that the gulf does not silence us. And if, lo, 2 decades later, a signal returns, a pixelated image of Proxima b, a spectrum of its atmosphere, a glimpse of its twilight zone, the achievement would echo across history. It would be the first time humanity looked upon a planet around another star, not as rumor, but as reality. The distance barrier is real. It is formidable. It is perhaps the greatest challenge any species has faced. But barriers are invitations. They are not the end of curiosity. They are its fuel. To ask whether we can reach Proxima b is to ask whether we accept limitation as destiny, or whether we dare to dream beyond. The answer lies not in the rockets of today, but in the visions of tomorrow. For though 40 trillion kilometers separate us, the first step has already been taken, the recognition that it is possible, if only we dare. And so the question remains, not if, but when. The dream of reaching Proxima b does not end with gram-scale sails drifting through interstellar night. For beyond these first scouts lies a larger vision, not of fragile machines, but of ships, vessels vast enough to carry humans, instruments, and the fragile seed of civilization itself. To imagine such journeys is to peer into technologies that stretch the very limits of physics. And yet, the path forward begins with an admission. The rockets of today cannot take us there. Chemical propulsion, magnificent in its ability to lift humanity into orbit, is a candle against the winds of interstellar distance. To cross 40 trillion kilometers, new fires must be lit, fires of nuclear energy, of antimatter, perhaps even of space-time itself. One of the boldest visions came in the mid-20th century, during the age of nuclear optimism. It was called Project Orion. Conceived in the late 1950s, Orion was not subtle. Its principle was as audacious as it was simple. Propel a spacecraft by detonating nuclear bombs behind it. The concept envisioned a starship equipped with a massive pusher plate, cushioned by shock absorbers. Each nuclear device, ejected and detonated at timed intervals, would hurl the craft forward with titanic force. The rhythm of destruction would become propulsion. With thousands of detonations, Orion could, in theory, accelerate a vessel to 10% of the speed of light. Freeman Dyson, the physicist who helped shape the project, believed such a ship could be built with then existing technology. Its scale was immense, thousands of tons, perhaps entire cities in orbit, propelled by the thunder of nuclear fire. But politics intervened. In 1963, the Partial Test Ban Treaty outlawed nuclear explosions in space. Orion was set aside, relegated to imagination. Yet the concept endures, a reminder of what might be possible if humanity ever dares to wield the atom beyond Earth. Orion embodies the paradox of nuclear power, immense potential, immense peril. To ride the fire of the atom may one day open the stars, but it requires the maturity of a civilization capable of balancing destruction and creation. If Orion imagined bombs, another vision imagines suns. Fusion, the binding of atomic nuclei, powers every star in the night sky. To master it is to hold starlight in human hands. In the 1970s, the British Interplanetary Society launched Project Daedalus, the most detailed study of interstellar fusion propulsion to date. The design called for a starship propelled by tiny pellets of helium-3 and deuterium, ignited in rapid succession by electron beams. Each miniature sun would burst behind the ship, driving it forward with unimaginable energy. Daedalus was vast, minus 50,000 tons of fuel, a structure the size of cities. But its ambition was equally vast. Accelerating to 12% of light speed, it could reach Barnard's star in half a century. For Proxima Centauri, the journey would take only 40 years. Daedalus revealed both promise and limitation. The physics of fusion are real, the energy abundant, but the engineering remains out of reach. Humanity has not yet built even a single power plant capable of producing sustained, practical fusion energy. ITER, the International Fusion Experiment in France, hopes to demonstrate net energy gain in the coming decades. If achieved, it would be a first step, not toward starships directly, but toward learning to hold starlight steady. Still, Daedalus ignited imaginations. It suggested that the journey to Proxima might not demand fantasy. It might demand only the mastery of what stars already do with effortless grace. More exotic still is the vision of antimatter. When matter meets antimatter, they annihilate, releasing energy with perfect efficiency. No fuel is more potent. A gram of antimatter colliding with a gram of matter releases energy equivalent to nuclear weapons. Harnessed for propulsion, antimatter could drive a spacecraft to extraordinary speeds. Antimatter-catalyzed fusion concepts imagine sprinkling tiny amounts of antimatter into fuel, triggering reactions far more efficient than bombs or beams. Pure antimatter drives imagined containment, rings filled with exotic particles, annihilating in controlled bursts to produce thrust. The obstacle is not physics, but production. Antimatter does not occur in bulk, naturally. Particle accelerators can create it, but in vanishingly small amounts, nanograms at costs rivaling the budgets of nations. To fuel a starship would require grams, even kilograms. For now, antimatter propulsion remains a dream, its brilliance shadowed by scarcity. And yet, its potential lingers like a beacon. If a civilization ever rises to the point of harvesting antimatter in quantity, perhaps from magnetic traps around gas giants, or through vast particle factories in space, the stars themselves would fall within reach. Beyond bombs, beyond fusion, Beyond annihilation lies a vision that borders on the mythical. To travel not through space, but around it. To bend the fabric of space-time itself. In 1994, physicist Miguel Alcubierre proposed a solution to Einstein's equations, now known as the Alcubierre metric. In principle, it allows a spacecraft to contract space in front of it and expand space behind it, riding a warp bubble faster than light without locally violating relativity. Within the bubble, the ship itself moves slowly, but the bubble carries it across distances faster than photons. It is a concept that resonates with science fiction, yet it arises from serious mathematics. The obstacles, however, are towering. The warp bubble requires negative energy density, exotic matter with properties not known to exist in usable form. Even if such energy could be found, the amounts required dwarf the output of entire stars. Some refinements proposed in the decades since suggest the energy requirements could be lowered. But for now, warp drives remain theoretical curiosities, reminders that the equations of relativity hold surprises, but also hold their secrets tightly. To imagine a warp bubble is to imagine humanity wielding not just fire, but the fabric of reality. Whether such mastery is possible or even desirable is unknown. Threaded through every propulsion dream is a single problem: energy. To cross interstellar space requires not only new engines, but new scales of power. Physicist Nikolai Kardashev in 1964 proposed a classification of civilizations by energy use. A Type 1 civilization harnesses all the energy available on its planet. A Type 2 civilization harnesses the energy of its star, perhaps through structures like Dyson spheres. A Type 3 civilization commands the energy of a galaxy. Humanity today is at only 0.7 on this scale. Not yet fully Type 1, our entire global consumption is a fraction of what strikes Earth in sunlight each hour. To build fusion starships or antimatter factories would demand leaps not just of engineering, but of civilization itself, a coordinated planetary effort to harness energies orders of magnitude beyond today. In this sense, interstellar travel is not merely a question of physics, it is a question of readiness. Are we prepared to wield the energies of stars without destroying ourselves? Can a species divided by borders and rivalries channel resources into collective futures rather than transient conflicts? The technologies of tomorrow sketch a path across the abyss to Proxima Orion with its thunder of bombs, Daedalus with its miniature suns, antimatter with its annihilations of perfect fire, Alcubierre with its bending of space-time itself. Each is possible within the laws of physics. None are possible yet within the grasp of humanity, but possibility is enough. It keeps the dream alive. It reminds us that interstellar travel is not forbidden, only postponed. The question that lingers is not whether the stars can be reached. It is whether humanity will become the kind of civilization capable of reaching them. Will we harness the atom without destroying ourselves? Will we master fusion not only in reactors, but in societies built for patience and endurance? Will we grow into the scale of a Type 1 civilization, or will we remain confined to our single, fragile world? To imagine Proxima b is to imagine more than a destination. It is to imagine a mirror. It reflects not just astronomy, but anthropology, not just physics, but philosophy. It forces us to ask, are we ready for interstellar civilization? For, in the technologies of tomorrow, lie not only engines, but choices. Choices about what kind of species humanity will become. Choices about whether we rise to the scale of stars, or remain bound to the soil from which we came. The stars wait with patience beyond time. The question is whether we will. The dream of reaching Proxima b is only half of the story. For beyond the barrier of distance lies the deeper question. If humanity could arrive, could it endure? Could fragile life, born under the steady gaze of a yellow sun, take root beneath the crimson glow of Proxima Centauri? The answer is not a simple calculation. It is a tapestry woven from physics, biology, and imagination, a meditation on survival at the edge of the possible. Proxima b is thought to be only slightly more massive than Earth, around 1.17 Earth masses. Its radius remains uncertain, but models suggest a world of rock and iron, dense enough to pull with a gravity similar to our own. To walk there might feel familiar, each step pressing into soil with almost the same weight. Muscles would not waste, bones would not fracture from weakness. It would not be like Mars, with its third of Earth's gravity, where generations might evolve with brittle skeletons. Proxima b, in this sense, might welcome us with a familiar pull, but gravity is more than comfort. It shapes atmospheres, holding gases close or letting them escape. If Proxima b is indeed Earth-like in mass, it could retain an atmosphere thick enough to breathe, to trap heat, to shield. The question is not whether it could, but whether it has. An atmosphere is the skin of a planet, and without it, life suffocates. For Proxima b, this is the central uncertainty. Orbiting so near its violent star, its air may already have been stripped away by centuries of stellar flares and particle winds. If so, the world may be silent, bare rock scorched on the dayside, frozen on the night side. But it is also possible that the planet still wears its veil of gases, a thick atmosphere, rich in carbon dioxide or nitrogen, could redistribute warmth, softening the extremes of tidal lock. Oceans might circle its equator, glimmering under perpetual twilight. Clouds might shield the surface, muting radiation. In some scenarios, Proxima b is not barren, but strange and beautiful, a world of crimson skies and alien seas. Water, the essence of life, remains the greatest mystery. Astronomers have found no direct evidence, but models suggest possibilities. Vast oceans, hidden ice, or nothing at all. The line between paradise and wasteland hangs on whether water survived the stars' storms, even if oceans endure. The sky above them would not resemble Earth's. Proxima Centauri is a flare star, prone to eruptions far more violent than our suns. In 2019, telescopes recorded a flare that brightened the star by 14 times in mere seconds. Ultraviolet and X-ray radiation poured into space, powerful enough to strip atmospheres and sterilize surfaces. For a planet orbiting so closely, this is not a rare catastrophe, but a frequent reality. Radiation would sweep across the dayside, ionizing molecules, breaking bonds, searing biology. To walk on the surface unprotected might be to stand in the path of invisible fire. Here lies the greatest barrier to survival, not gravity, not water, but the wrath of the star itself. Yet survival does not demand perfection. It demands adaptation. One possibility lies beneath the surface. Humanity could build underground, carving cities into rock, shielded by meters of stone. Radiation that scours the surface would fade in the depths, leaving air and water stable. The subterranean world, lit by artificial suns, could sustain generations. Already, Earth's own extremophiles thrive underground, feeding on minerals and chemical energy. Humanity could follow their example, retreating from hostile skies into protective stone. Another vision imagines domed habitats, their shells layered with water or polymers to block radiation. These cities would be islands of safety under an alien sky, their walls glowing with the filtered light of a red sun. Within, Earth-like air would circulate, plants would grow, and human lungs could breathe freely. A more audacious solution lies in engineering the planet itself. Magnetic shields, vast superconducting loops, powered by nuclear or fusion energy, could deflect charged particles, mimicking Earth's magnetosphere. Positioned in orbit or at key points in the planet's magnetic field, they could restore what the star has stolen: protection. The cost would be staggering, but the principle is sound. In theory, humanity could cloak a world, but perhaps survival on Proxima b is not about shielding against difference. Perhaps it is about embracing it. Life on Earth is resilient. It thrives in boiling vents, in frozen tundra, in radioactive wastes. Some organisms endure without sunlight, feeding on chemistry alone. If Earth's biosphere is any guide, then life, if it arose on Proxima b, may not fear its star. It may have adapted to radiation, evolving pigments that absorb ultraviolet, or biochemistry that repairs damage swiftly. Its oceans, if they exist, may shelter it under kilometers of protective water. Humanity, too, might adapt. Future generations could alter themselves through biotechnology, enhancing DNA repair, resisting radiation, or even incorporating traits borrowed from Earth's extremophiles. Colonists might no longer be entirely human by today's definition, but hybrids of biology and necessity. In this vision, survival on Proxima b would not mean transplanting Earth intact. It would mean transformation. Perhaps the most haunting possibility is that survival lies not everywhere, but in a narrow band, the Terminator line. On a tidally locked world, one hemisphere roasts in perpetual day, the other freezes in eternal night. But along the boundary between, where light meets dark, temperatures may stabilize. Here, in an endless ring of dusk, the climate might be temperate, the winds circulating warmth and cold into balance. This twilight band could be the most habitable region of the planet. Colonists might live in a perpetual sunset, the red star forever low on the horizon, shadows stretching endlessly. Crops could grow under constant dim light, powered by technology, as much as photosynthesis. Cities might circle the planet in a band of dusk, never moving, never changing. A civilization of eternal evening. It would be alien, but it would be survivable. Every possibility, however, comes with fragility. Underground cities demand energy. Domed habitats demand constant repair. Magnetic shields demand planetary-scale engineering. Adaptation demands rewriting what it means to be human. Even the Twilight Zone, if habitable, may be narrow and precarious, vulnerable to shifts in climate or loss of atmosphere. Survival on Proxima b, if possible at all, would not be comfortable. It would be hard-earned, fragile, always at risk. Humanity would not thrive there in the way it thrives on Earth. It would endure. And yet, endurance is what defines life. Life is not promised gentle skies. It is promised challenge. The history of Earth is the history of survival through catastrophe, impacts, extinctions, ice ages, fire. To survive on Proxima b would be to continue that history on a cosmic scale. Philosophically, the question becomes profound. To survive on Proxima b may not mean preserving humanity as it is, but becoming something new. Survival might require merging with machines, altering biology, adapting to radiation, embracing perpetual twilight. The humanity that thrives there may not be the humanity that left Earth. This possibility forces reflection. Is survival enough if it changes what we are? Or is transformation itself the essence of survival? Perhaps humanity has never been fixed, but always in motion, from hunter-gatherers to astronauts, from caves to cities, from Earth to stars. Proxima b, in this sense, would be only the next chapter in an endless metamorphosis. Could we survive there? The answer is not simple. It is not yes or no, but a spectrum of possibilities. If the atmosphere endures, if oceans glimmer, if technology shields, then yes, survival is possible. If radiation strips, if water vanishes, if fragility overwhelms, then no, the dream collapses. But even uncertainty carries meaning. Proxima b reminds humanity that survival is not about perfection, but persistence. The crimson star does not offer comfort. It offers challenge. And in that challenge lies the measure of what it means to be human. For to step upon Proxima b, to breathe its air or shelter under its soil, would be to prove that life can stretch beyond its cradle, that survival is not limited to one sun, one planet, one sky. It would be to declare that even under hostile stars, life endures. Perhaps one day, under the eternal twilight of Proxima b, humans will walk. Perhaps they will live in domes that glow like lanterns against the crimson dusk, or in caverns warmed by artificial suns. Perhaps they will no longer look exactly like us, but their voices will still tell the story of Earth, of oceans and skies. Remembered, and perhaps, in that distant time, they will look back across the gulf of 4.24 light years and realize what survival means. Not permanence, but transformation. Not comfort, but resilience. Could we survive there? The answer is that survival itself may demand becoming more than human, shaped not by Earth, but by Proxima. The vision of Proxima b is more than astronomical. It is existential. For when humanity imagines walking beneath its crimson sky, it confronts questions, not of physics, but of meaning. Could we survive there? Yes, perhaps. But should we? And what does the search for another home reveal about us here on Earth? To contemplate colonizing another world is to stand at a crossroads of morality. Earth remains wounded, forests burned, oceans rising, atmospheres warming under the weight of our industry. Millions still lack stability, justice, or security. In this light, the dream of Proxima b appears both magnificent and troubling. Should a species that struggles to safeguard its own planet extend its reach to others? Some argue that the very impulse to leave is an abdication of responsibility. That seeking refuge among the stars risks treating worlds not as sacred but as escape routes, that before humanity builds domes on Proxima b, it must first heal the only home it has known. Yet others argue the opposite, that exploration is not abandonment, but continuation, that the same spirit which drives humanity to preserve Earth also drives it to extend beyond it. To remain confined, they say, is to risk extinction from asteroid, from climate, from nuclear fire, from the slow entropy of the sun. Survival, they insist, demands reaching further, not retreating inward. The ethical tension cannot be erased. To dream of Proxima b is to walk a narrow path between wonder and responsibility, between exploration and hubris. Searching for another home says as much about Earth as it does about the stars. In Proxima b, humanity sees not just a planet, but a reflection of itself. Its possibility of habitability mirrors our longing for safety. Its fragility mirrors our fear of loss. Its hostility mirrors our awareness of how easily paradise can become barren. To imagine Proxima b is to confess that Earth may not be eternal. It is to acknowledge mortality on a planetary scale. This acknowledgement is unsettling, for if our home is fragile, then so are we. Yet, within this fear lies a deeper current hope. The very fact that humanity searches for another home reveals optimism. It reveals a refusal to accept finality, a desire to carry life's flame across the void. The paradox is stark. The search for other worlds arises from despair, but also from courage. Would humanity seek Proxima b out of necessity or out of wonder? Exile has been written into human history. Peoples have fled famine, war, and disaster, carrying seeds and stories into new lands. If one day Earth falters through ecological collapse or cosmic accident, Proxima b may appear as refuge, a distant ark for survival. In that future, exile would be necessity. But there is another vision, that humanity may journey, not because it must, but because it chooses. That Proxima b would call not as refuge, but as frontier, a canvas upon which to inscribe curiosity. In this vision, to step beneath its skies would be an act not of desperation, but of wonder. The paradox is that both visions coexist. Humanity dreams of Proxima b because it fears the end, but also because it longs for beginnings. It is both survival and exploration, exile and adventure. Beneath the poetry lies a practical question. Does humanity have the right to extend itself to other worlds? If Proxima b is barren, perhaps the question is simpler. A lifeless rock may be transformed without moral injury. But if life exists, microbial, alien, fragile, then colonization becomes intrusion. The ethical frontier expands outward. Does humanity owe respect to life, not its own? Does even a single microbe under a crimson sky deserve protection from human ambition? Some philosophers argue that life, any life, carries intrinsic value, that to overwrite alien biology with human civilization would be an act of cosmic colonization, repeating old mistakes on a grander scale. Others argue that survival demands pragmatism, that if life exists, humanity might coexist, or reshape, or absorb. For the sake of continuity, the question cannot yet be answered, for we do not know what Proxima beholds. But the very act of asking reveals that colonization is not only technical, it is moral. What Proxima b ultimately reflects is not certainty, but fragility. The possibility that it has no air, no seas, no shield against radiation. This mirrors the awareness that Earth itself is delicate. Our atmosphere, too, could be stripped. Our oceans, too, could vanish. Our magnetosphere, too, could falter. Proxima b reminds us that habitability is not inevitable. It is a rare equilibrium, balanced on the edge of chance. To dream of surviving elsewhere is to be reminded of how precious survival here truly is. The Kardashev scale, which measures civilizations by their energy use, also invites ethical reflection. To reach Proxima b requires not just energy, but maturity. A Type 1 civilization, harnessing the resources of its planet, must also learn to wield them responsibly. A Type 2 civilization, drawing power from a star, must learn to wield it without devouring itself. The journey to Proxima is not only about propulsion or shielding. It is about whether humanity can mature into a civilization worthy of the stars. Worthiness is not a scientific measure, but an ethical one, defined by whether we destroy or sustain, whether we exploit or respect, whether we repeat old mistakes or transcend them. In the end, Proxima b is less a destination than a reflection. It reflects humanity's fears of collapse, of loss, of exile. It reflects hopes of survival, of renewal, of transcendence. It reflects limitations of energy, of morality, of imagination. To gaze at Proxima b is to gaze at ourselves. The planet itself remains unseen, known only through data and inference. Yet in our minds it is vivid, oceans or deserts, twilight or wasteland. What we see there is shaped less by astronomy than by psychology. It is the canvas upon which humanity projects its anxieties and aspirations. The ethical and philosophical frontiers of Proxima b are vast. Should we go before we have healed Earth? Should we alter ourselves to survive beneath a hostile star? Should we claim a world that might already hold life? These questions are not answered by telescopes. They are answered by who we choose to be. Perhaps the greatest lesson of Proxima b is that the frontier is not only outward, but inward. Before humanity crosses 4.24 light-years, it must cross the distance within itself, between division and unity, between exploitation and stewardship, between fear and wonder. Proxima b may one day host our descendants, or it may remain a dream, a mirror hung in the sky. Either way, it reveals something profound, that to seek another home is to seek ourselves. The story of Proxima b does not end with discovery, nor with speculation. It continues in the patient gaze of telescopes, in the algorithms of data, and in the imaginations of scientists who persist in listening for whispers from the nearest star. The mystery is alive not because it has been solved, but because it resists resolution, compelling humanity to look again, to refine, to dream today. A constellation of instruments works in concert, straining to glimpse what no eye has ever seen. The Transiting Exoplanet Survey Satellite, TESS, sweeps across the sky, monitoring the brightness of hundreds of thousands of stars, watching for the telltale dip of a planet passing in front. Proxima b does not transit from Earth's perspective. But the methods honed by TESS refine the tools with which other worlds are studied, each lesson feeding into the next. Gaia, the European Space Agency's astrometric observatory, maps the precise positions and motions of over 1 billion stars. Its data allows scientists to refine the wobble of Proxima Centauri itself, constraining the masses and orbits of its planets. Each update narrows uncertainty, turning faint signatures into clearer truths above them all. The James Webb Space Telescope peers into the infrared hunting atmospheres around distant worlds. Though not designed specifically for Proxima b webs, sensitivity may yet capture subtle variations in light that betray the gases of its skies or the heat patterns of its surface. Already, Webb has begun characterizing atmospheres of other rocky exoplanets, building a library of comparisons against which Proxima b's nature may one day be inferred. But it is the next generation of telescopes that holds the greatest promise. On a mountaintop in Chile, the European Extremely Large Telescope, the ELT, rises slowly against the desert. With a primary mirror 39 meters across, it will be the largest optical telescope ever built. Its adaptive optics will sharpen starlight into clarity, allowing it to directly image exoplanets circling nearby stars. Proxima b may remain too faint for a perfect picture, but its siblings, larger and more distant from the glare of their stars, may be revealed in unprecedented detail. Other instruments, the 30-meter telescope in Hawaii, the giant Magellan telescope, also in Chile, join the race. Together, they will push exoplanet science from inference toward vision, from signatures toward landscapes. Even more ambitious are space-based concepts. The Habitable Worlds Observatory, proposed by NASA, aims to launch in the 2040s, equipped with coronagraphs or shades. It could block the glare of starlight to reveal Earth-like planets directly, perhaps even Proxima b itself. For the first time, humanity may see not just numbers and models, but the pale reflection of oceans, the shimmer of clouds, the fingerprint of biology. To directly image a planet like Proxima b would be a revelation. A single pixel, colored by its reflected light, could reveal oceans or deserts. Spectra could identify oxygen, methane, carbon dioxide, the breath of a living world, or the silence of a barren one. Direct imaging is no longer fantasy. It is within the reach of instruments under construction today, or designs in the near future. Within decades, humanity may finally look upon Proxima b not as wobble or equation, but as world. And yet, even then, distance will remain. No telescope, however vast, can walk its landscapes or taste its air. The gulf of 4.24 light-years is indifferent to our impatience. It allows only light to cross. Each discovery brings us closer, yet also underlines how far away we remain. To know that Proxima b exists is wondrous. To know that it may have an atmosphere is profound. But to stand there, to breathe its air or shelter under its skies, is another matter altogether. The gap is not only physical, but temporal. It is the gap between knowledge and presence, between imagination and reality. In this sense, the study of Proxima b is both exhilarating and humbling. It reminds humanity that science can extend vision across trillions of kilometers, yet cannot yet bridge them with footsteps. The paradox persists. The nearest world is near enough to imagine, but distant enough to elude, and still the dream endures, not because it is easy, but because it is possible. Unlike distant galaxies, Proxima Centauri is close enough to conceive. Unlike myth, it is grounded in data. Unlike abstraction, it is tangible, a planet orbiting the star next door. This nearness matters. It turns speculation into strategy. It makes projects like breakthrough starshot fusion concepts or future observatories meaningful. If Proxima b were 100 light-years away, its study would remain academic. But at 4 light-years, it becomes personal. It is a neighbor, unreachable yet imaginable. That imagination is powerful. It fuels funding, innovation, and curiosity. It stirs a species to look outward, even while bound to one world. The path ahead is not clear. In the coming decades, telescopes will sharpen their gaze, revealing atmospheres, climates, perhaps even biosignatures. Starshot probes may one day race outward, carrying cameras the size of grains of sand, whispering back glimpses of alien sunsets. Human starships remain beyond reach, but not beyond thought. What Proxima b offers is not certainty, but vision. It reminds humanity that the future is vast, that discovery is not a moment but a process, and that the stars are not silent, they are waiting. The dream of Proxima b remains alive, not because the way is easy, but because the destination is near enough to touch in imagination. And in that act of imagining, humanity finds itself fragile, curious, restless, forever leaning toward horizons not yet crossed. In the dark of the southern sky, Proxima Centauri glows as a faint ember, its presence nearly erased by brighter companions. Around it circles Proxima b, unseen, uncertain, yet profoundly imagined, the nearest possible Earth, and perhaps the most unreachable. It is the paradox of proximity, just beyond the reach of present technology, yet close enough to linger in thought. It is the nearest impossible dream. For more than a century, humanity has lifted its gaze to the stars, seeking reflections of itself, first with wonder, then with telescopes, and now with instruments that measure the trembling of light with the precision of atoms. Each step has widened vision, but none has erased distance. The universe remains vast, uncompromising, patient, and yet the dream persists, not because it is simple, not because it is likely, but because it is essential. Humanity's story has always been tied to the heavens. Ancient navigators steered across oceans by starlight. Farmers traced the rhythm of seasons in constellations. Poets inscribed destiny among the constellations that drifted overhead. The stars have been compass, calendar, and canvas. But now they are something more, potential. They are destinations. In Proxima b, that potential sharpens into clarity. For light years is not an abstraction. It is measurable, almost tangible. It is a threshold that asks, can we cross? Even if we never set foot there, Proxima b binds our fate to the stars. It reminds us that Earth is not infinite, that the sun itself is not eternal. In billions of years, the seas will boil, the atmosphere will vanish, the planet will die. Long before then, humanity must decide, remain or reach outward. The stars are not simply dreams, they are necessity, written into the timeline of existence. But the deeper truth is this: the value may not lie in the arrival, it may lie in the pursuit. To imagine Proxima b is to imagine more than a planet. It is to imagine human persistence, the willingness to strive for what may never be attained, the courage to face distance, fragility, and limitation, and still press forward. Every advance in astronomy, in propulsion, in energy, arises not from certainty of success, but from refusal to accept silence. The journey defines us more than the destination. For even if humanity never builds starships, the act of trying will have reshaped civilization, uniting nations, advancing technologies, deepening philosophy. Proxima b becomes not only a world in orbit, but a mirror of the human spirit. In truth, Proxima b may be barren. It may be airless, oceanless, blasted by radiation. It may never cradle life, nor welcome our descendants. But this does not diminish its meaning. For it is not only the possibility of habitability that draws us, but the act of longing itself. Humanity longs because it is restless. It seeks horizons, even when horizons recede. This longing is not weakness, but strength. It is the thread that carried us from caves to cities, from continents to orbits. It is the thread that binds survival to imagination. Proxima b embodies that longing. A world unseen yet vividly alive in thought. A world too near to ignore, too distant to embrace. Perhaps, then, the question is not whether we can live there, but what it means that we dream of living there. The pursuit itself defines us. To be human is to be a seeker of horizons, even those beyond reach. To stand beneath a sky of stars and feel that it calls, even when it cannot be touched. Every generation inherits this calling. The Polynesians sailing by starlight, the astronomers charting orbits, the engineers building telescopes, all are bound by the same impulse to move outward. Proxima b is the next horizon. Whether reached or not, it shapes identity. For if one day a signal arrives from a probe, a pixel of ocean, a spectrum of air, humanity will have crossed more than distance. It will have crossed the boundary between imagination and reality. But even if no such signal comes, the attempt will have defined us as beings unwilling to accept confinement. Proxima b is the nearest impossible dream. It hangs just beyond reach, a reminder that the cosmos is both generous and merciless, offering visions of other homes, but guarding them with distance and fragility. Yet it is enough. For the dream of Proxima b affirms that humanity is not static. It is a species that seeks, a species that wonders, a species that, even when faced with impossibility, leans forward into the dark. The question is not only whether we can live there. The question is whether the pursuit itself is our destiny. To seek horizons that may never be crossed. To chase suns that may never be reached. To carry the fire of longing into the infinite night. And perhaps, in the end, that is the true home. Not a planet under a crimson star, but the act of seeking itself, the unquenchable longing for another sun.